Next up is question 4 on the worksheet. It says find the equation of the plane that passes through the points P with coordinates 1, 0, 3, Q with coordinates 0, 4, 2, and R with coordinates 1, 1, 1. Alright, so drawn a picture here. We have our plane with these 3 points in the plane. And the idea is to first generate a normal vector for this plane. And then, since I actually have 3 points in the plane, I can take my pick. Once I know a normal vector and a point on the plane, then I can come back to this scalar equation that we derived in the first video to write down an equation for this plane. Alright, so let's first go ahead and construct these vectors P, Q, and PR. Okay, since the points P, Q, and R all lie in the plane, these 2 vectors, P, Q, and PR, are parallel to our plane. And so if I take their cross product, this vector n will then be a vector normal to our plane. Okay, so I go ahead, I have PQ and PR here. I take the cross product and I get this vector -7, -2, -1. Okay, so this is a normal vector for this plane. And for a point on the plane, as I already noted, I actually have 3 points. I'm just going to choose point P, but you just as well could use Q or R. But I'll use P with coordinates 1, 0, and 3. So then we just put that all together using this scalar equation up above, right? So the -7, -2, and -1, those are these coefficients you see right here, here, and here. And then 1, 0, 3, those go in for x0, y0, z0. And then I go ahead and do a little bit of simplifying. I get 7x plus 2y plus z is equal to 10. And by the way, you can easily check that the coordinates of all 3 of these points satisfy this equation by just plugging the respective coordinates in for x, y, and z, right? So for P, if I plug in 1 for x, 0 for y, and 3 for z, I get 7 plus 0 plus 3, well, that is 10. For Q, plug in 0 for x, 4 for y, and 2 for z. That's going to give you 8 and 2 is 10 again. And then lastly for R, plug in 1 for x, y, and z. That gives you 7 plus 2 plus 1. Well, again, that comes out to be 10. So it works. All right, great. So then let's check out question 5 next. This says, find the equation of the plane that contains the line given by this vector function r of t, which is t, -t, 2t, and passes through the point P with coordinates 1, -2, 3. All right, so I've drawn a picture up here. So we have our plane, we have this line that lies in our plane, and then we have this point P over here. Now again, just like in question 4, the 2 key things I need to write down an equation for this plane are a normal vector for the plane and a point on the plane. All right, so how can I go about finding a normal vector? I'm going to first note here, going back to, this is section 12.5 when we introduced lines in space. Okay, I'm going to write down this direction vector for the line. Since our line lies in the plane, okay, this direction vector v, which remember we can find by just reading off the coefficients of the parameter, so 1, -1, 2, okay, this vector v, okay, will lie parallel to this plane. Okay, so then what's another vector that's parallel to our plane? Well, I'm going to build that by just choosing a point on the line, and I can choose any point on the line. I'm going to go ahead and choose the point P0 with coordinates 0, 0, 0. And why do I know that this point is on the line? Well, I just use this vector equation that describes all points on the line, right? So if I, in particular, plug 0 in for the parameter t, okay, this gives me the position vector 0, 0, 0, which in turn implies that this point P0, right, which is really just the origin, it lies on this line. And now what I'm going to do is form this vector P0P. Okay, since P0 and P both lie in this plane, the vector P0 to P will be parallel to this plane. And now, right, I have 2 vectors that are parallel to our plane. So just like in question 4, I'm now going to go ahead and take their cross product, and that's going to give me a vector normal to this plane. Okay, and the cross product comes out to be -1, 1, 1. And so I have a normal vector, right, -1, 1, and I have a point on the plane. Now, I'm going to actually use P0, right, which again is just the origin, just because, right, that'll make the resulting cleanup a little simpler. I could, of course, also use the point P given in the problem, right? Its coordinates are 1, -2, 3. Both options would work. But in any event, I go ahead now and build our equation just using this general form for the scalar equation up above. I get negative quantity x minus 0 plus y minus 0 plus z minus 0 is 0. Rewriting, I get x minus y minus z is equal to 0. All right, and that does it for these two questions. Thank you so much.